The first thing we do with any limits problem is to try a direct substitution. I can tell if I plug in -3 on the top, I am going to get 0, and I'm also going to get 0 on the bottom. So there's two ways you can do this problem. You can either go ahead and factor. So both the top and the bottom do factor nicely. So x plus 3x minus 1 over 2x minus 3 over x plus 3. And then if I go ahead and plug in -3, I'll get a -4 on the top and a -9 on the bottom. So my limit would be 4/9. Or you could do L'Hopital's rule. So anytime you have 0 over 0 or infinity over infinity, you can go ahead and do L'Hopital's rule. So the derivative of the top is 2x plus 2. The derivative of the bottom is 4x plus 3. And if I plug in a -3 here, this is a -4, and I get the exact same thing. So either way works. Okay, this one here, I'm going towards infinity, and remember we've done these problems from the beginning. If you're just talking about polynomials on top and bottom, if the degree on the bottom is bigger, we know that the fraction gets smaller and smaller in the long run. You can do L'Hopital's rule, but you will have to do it 2 times to get to that. Okay. If I plug in 0, remember, always try direct substitution. Cosine of 0 on the top is 1. On the bottom, you have 0. So the bottom of the fraction is getting smaller and smaller. The top is a number. So the entire fraction is getting bigger and bigger. So this is infinity. So this is not L'Hopital's rule because you ended up with 1 over 0. Remember, L'Hopital's is only if you have 0 over 0 or infinity over infinity. Okay, number 4. If I plug in infinity, I get infinity because e to the infinity is infinity. Natural log of infinity is also infinity because if you think about the log graph, this does grow infinitely bigger. It just does it at a very slow rate. So you can either do L'Hopital's rule. So L'Hopital's rule would give me, if I do the derivative of the top, 3e to the 3x. The derivative of the bottom is 1 over x. And clean this up, though, before you start plugging in the infinity. So I'm going to flip that bottom fraction, so I end up with this. And now if I plug in infinity, I just have infinity. Or if you understand the idea that you have an exponential on the top, I have a log on the bottom, the top is going to grow at a much faster pace. So I know that this gets bigger and bigger in the long run. Okay, limit of a constant, this will always just be 10. Okay. This one here is a direct substitution. If I plug in 2 here and 2 here, you have 0 squared. 0 squared is just 0. Right? Some of these are just going back to direct substitution. This one here, if you plug in infinity, you do get infinity over infinity. So if we do L'Hopital's rule, but then this simplifies to x. So now if I plug in infinity, I get infinity. Or notice the top function is x, and you are taking the log of the exact same function. So when you take the log of a function, it slows down the growth. So I actually do know the top is growing at a faster rate. So either way works. Remember, again, we're just comparing degrees here. But square root of 4x squared, remember, is the absolute value of 2x. And we're going to think of the positive scenario because we're going towards positive infinity. So really, this just gives me 2 as my limit.